Hello all, welcome to this video on WiMonitor Enterprise, and in this video we are going to be looking at important database fields, what they mean and how we can use them. So let's get started. Now in a previous video we've seen the Discover panel in which we see different packets listed and important features from those packets have been extracted, and those features are available to us in the form of database fields we can query and visualize. So let's now look at a couple of important fields and understand what they mean so that you can use Kibana more effectively. Now the first field is the timestamp field. Now this field indicates the exact time when the packet was processed and indexed into our database. So let's take a look. Now the timestamp field is actually present in every packet. I'm going to increase my font size just to make it a lot more easier to read everything. So here we can see we have our timestamp field, and what you would notice is if you looked at every single packet, all of them have this specific field. Now the next field I want to look at is the WLAN frame name. So the frame name is really a human readable name with which we can apply filters, search, etc. Now, as I mentioned earlier, WiMonitor Enterprise looks at a subset of management and data frames which have a bearing from a security perspective. So the ones currently supported include beacon, data, probe request, probe response, and deauthentication. Now, it is important to note that these frame names are case sensitive. So let's actually go ahead and look at the frame name. So again, we are in the Discover panel, and I've already captured a lot of packets, and we are looking at that. So I'm going to go down and go to frame name. Here it is. And if you notice, this is a data frame. Now, we can look at the different type of frames available in our capture. And we can do that very, very easily by locating frame name. Here it is, clicking on it on the left hand side. And this gives us some idea of the distribution of the different values WLAN frame name has. Now we could click on visualize right here, and this would give us a simple bar chart with different names. So as you can see, beacon, data, probe response, probe request, and deauth. Fantastic. So let's go back. Now, one place where you can use any of these fields is basically to go ahead and apply filters. So let's say in all of these 17,483 packets, I'm only interested in looking at, let's say, deauthentication frames. Then I can click on add filter, search for WLAN frame name, there it is, and I can say is, and then I can type in deauthentication. We have all these values in here. As I mentioned, this is case sensitive, so we can type in deauthentication. Let's label this deauth frames. Save it. And now what you would actually notice is what we are able to see is only deauthentication frames. Within this capture is only one frame. Now, if you want to go ahead and remove the filter, all you have to do is click on the delete button over here. And the filter gets removed, and you notice the one hit which matched the filter now goes back to all available hits, which is 17,483. Similarly, we could actually type in a filter for probe responses. So I'm going to say probe dash response. Of course, you can create a label so it's easily understandable when you look at it. And there you go, we have 413 hits for probe responses. Fantastic. So frame names definitely are important, and you would see yourself filtering by WLAN frame name many a time. Now, apart from this, what we've also done is given a couple of convenience attributes, in the schema. One of which is access underscore point underscore SSID. So what we've done is whenever we go ahead and analyze beacon frames, we automatically generate this value called access underscore point underscore SSID and pass on the access point SSID to this variable. Now keep in mind though that SSIDs of course can be any SSID that the user or the admin is setting, and can also be a hidden SSID or a non-broadcasting one, which means the beacon frames are sent but the SSID is absent within it. Now in such a case, what we've done is we've created a special value which is hidden underscore SSID, all uppercase, which gets assigned to this field. So let's go ahead and as an example, first filter for all beacon frames. Frame name is beacon. Now once we do that, of course, each of these beacon frames should have an access underscore point underscore SSID field somewhere, and we can clearly see here it is. There you go, access underscore point underscore SSID. We'll make this a little bit bigger. There you go. Right? Okay, too big. Fantastic. Now we can even create a visualization with such a specialized field. So I could actually go click on visualize, click on a new one, could go in here, create a tag cloud, select Wi-Fi, and I can basically say, well, the field you can use could be access point SSID, and the size, let's say the top 10. And of course, if count is selected, it's really the number of beacon frames. And there you go. We see some values in here. Fantastic. So the next thing we want to look at, of course, is probed SSIDs, right? We know that clients send out these periodic probe requests. And of course, they can be null probe requests, and which is denoted by the value null underscore SSID, or they could be probing for access points which they've connected to before, and they're trying to see if those APs exist in the vicinity. So this is again another convenience feature where what we would have to do is, let's actually go back and create a simple visualization with this. You could click on the tags, change this to probed SSID, let's say the first 100, and there you go, we get some probed SSIDs. Now null SSID, of course, what that means is that this is nothing but a null probe request. Again, very good convenience feature. Now, if you recall from the 802.11 header, we have the WLAN frame control field, right? So within the frame control field, of course, you have the version, the type, subtype, of course, type and subtype as separate values can be extracted as well. The toDS field, the fromDS field, retry, power management, protected, order, more data, etc. So of course, This is similar to what you see in Wireshark and the kind of filters you would apply. And this is exactly the same thing which we have over here. So this entire section of every single Wi-Fi packet which we have consists of the WLAN frame control field and different values for each of the subfields. So this is again something, if you want to go ahead and do some analysis, you could use these fields. Now after that, we have the WLAN address fields. Again, if you used Wireshark Wi-Fi, you already know WLAN ADDR. WLAN DA stands for destination address, SA source address, BSSID, RA for receiver address, TA for transmitter, and STA for STA address. Now for each of these addresses, we have of course the base value, which is the WLAN underscore ADDR as an example, and that's basically the MAC address, the hex representation. Then for the same address, you actually have a WLAN, whatever ADDR as an example here, vendor, where if we've managed to detect the vendor name, then the vendor name is there. And there is another which is basically underscore resolved. And if we manage to resolve the vendor, then we substitute the vendor here, but we leave the last 3 bytes as is. So it's easy for an analyst to kind of look at the more significant digits in differentiating between 2 MAC addresses even belonging to the same vendor. Now this is something we've done for all of the WLAN address fields, and if you jog your memory in 802.11, you typically have 3 address fields, and you can have up to 4 address fields if WDS is being used, right? So I'm not going to go into details of these address fields. Ideally, if you've done 802.11 monitoring and security, then you should remember. If not, go through our online videos or go through any book, and you should be able to figure out what these address fields mean. But again, the exact same names, as Wireshark uses. So this should be a 1-to-1 mapping. Now, if you notice, these fields are scattered around. So we have the WLAN underscore ADDR fields here. We have the WLAN BSSID fields here. Then you have the WLAN DA destination address here. Of course, this is all alphabetical. So you're going to be having the RA part here, the WLAN underscore SA part here, and then finally you have the STA part here, right? Followed by the TA part here. So again, you would need to go ahead and look at this, figure out which packets have which fields and their significance and all of that stuff. But we have everything in there, so you can add arbitrary queries and filters. Okay. Now the next interesting thing is the Radiotap header fields. Now this is interesting because to you as an analyst, this will tell you exactly where the packet came from, so which band, what channel, what data rate, and at what signal strength. There are a couple of other fields in here as well, and if you really love 802.11, you might find use for it, or else it's kind of good to have. So let me explain these fields. So the most important field, of course, is WLAN underscore radio underscore PHY or physical. And if you notice, the value 4 indicates 802.11b, the value 5 indicates 802.11a, 6 for G, 7 for N, and 8 indicates AC. And what I've done is I've actually taken screenshots from 3 different packets. One for 802.11 here, A here at the bottom, and then you have N here on the right, and then AC here at top left. So once you know the physical, the other interesting metric, of course, is WLAN radio signal dBm, and this is the signal strength at which this packet was received. Now, this is always going to be a negative dBm value. And we can see here it's minus 52 dBm, minus 62, and here it's minus 83. Again, depending on if you're doing some kind of a proximity analysis, then this value can give you some indication if you are kind of receiving this value for a device over a long period of time. Now, apart from these two fields, you also have the channel field, WLAN radio channel. Now, for A, this is currently set to 56 for the A packet, and likewise other values for the remaining two packets. Similarly, you have data rate. This data rate is in Mbps, and we can see the data rate here is 6. The data rate here for the 11AC packet is 780, and for the N packet which we captured here is 13 Mbps. Now, apart from the data rate, you also have frequency. This is really nothing but, the conversion of the channel. Again, it's good to have. I personally prefer to work with channels rather than frequencies, but we've still kind of left it in there. Now, apart from this, you also have other fields which may talk about, HT and VHT aspects, which is high throughput and very high throughput. So as we can clearly see in the case of 11AC, you have WLAN radio 11AC bandwidth, and this might indicate if this is 20, 40, 80, 80 plus 80, 160, all of those combinations. And similarly, you have WLAN radio 11AC user. So this gives you the MCS values and all that, based on which things like speed, etc. can be calculated. The same thing applies here for 11N. Now these two fields, which is the bandwidth, the MCS value, the user, typically you would not use unless you really are trying to do some kind of an in-depth statistical analysis. From the Radiotap headers, what I typically use for security, of course, is the channel where I received the packet on, which is WLAN radio channel. The rate is interesting. Why? Because ideally I should be able to see a lot of high data rate packets, like the one here, 780 megabits. This clearly shows me that we are able to go ahead and sniff and monitor high speed data packets, which is of course one of the main reasons why you're using the WiMonitor Enterprise Edition. Fantastic. Let's actually look at some examples. So if you notice, here is all the radio part. Here is an example. So we can clearly see WLAN radio underscore PHY is 8, which means this is 11AC packet, as I've indicated here. Then you have the radio frequency. This is basically 5.32 gigahertz. Then you have the channel 64, the data rate 780 megabits, and then of course the bandwidth and the user fields, which give their respective values. Finally, you have the signal strength, which is set to -52. Now, the base values, which is the radio channel, data rate, frequency, physical, signal dBm, this is available for all packets. Depending on if you're using 11N, which is HT, or 11AC, which is VHT, you may have these two additional fields also available in the packet. So that is important to note, is only in the case of 11N and AC, those two extra fields come in. But again, as I said, you might not use it too much from a security perspective, but it's interesting to have them in there. Okay. Apart from these, we have some metadata as well. So one is packet length. So if we go up here, we have packet length, so which is 174, and of course packet length itself can vary in a huge way. Before actually we move on, maybe we can just spend a minute to see how we can figure out what kind of a capture we have, right? So WLAN radio physical, we said ABG and AC, these are the values. So we could actually go in here, locate WLAN radio physical, here it is, and then click visualize. And there you go. You can clearly see this is 11AC, then you have 4, which is 11B, and then you have 5, which is 11A. we see some 6 which seems to be G, and then you have 7 which is N, and that's about it, right? So you can clearly see that WiMonitor Enterprise across the spectrum has captured from multiple bands, right? This is good validation that the monitoring and capturing process is going on well. Of course, the assumption is that wherever you're collecting packets, these bands are occupied and there are devices transmitting packets, right? Or else there is absolutely no way that you can capture these packets. Okay, let's hop back. The next metadata field is all layers. Now we know that, any single network packet has multiple layers, right? You have the lower layers which may deal with transport, higher levels which may deal with application specific data. So all layers is really a colon separated list of layers which we've detected in the packet. So typically a pure WLAN packet like a management packet would only have, let's say, the Radiotap header, the WLAN radio header, followed by the WLAN header, right? Data packets may actually have more. So as we can see over here, this classification has Radiotap, WLAN radio, WLAN, but then has LLC IP TCP data, which means this is a TCP data packet. And you can see some variations where we can see ARP here, we can see DNS over UDP, and you can even see HTTP, of course, which is using TCP. Now, apart from this meta field, we also have just the top layer, which is, of course, the topmost layer taken out of, the all layer field, and which could have values like WLAN just data, in which case we aren't able to detect what kind of data packet this is using Wireshark's engine, or TCP, HTTP, ARP, DNS, etc. So let's go back and take a look at these fields. So here is the all layers field, as we can see here, and then you should have top layer, which is here. Now, for both of these, we can go ahead and try to quickly visualize them. Of course, this isn't the best visualization. I would prefer a tag cloud in this case. I'm going to go create a tag cloud. So this is all layers. I don't care how many we get, so I'm just going to put 15 here. And there you go, right? And this is the larger, any of these are, the more number of packets we've captured with that exact layer breakup, right? And of course, clearly we have a lot of plain WLAN management packets and plain data packets, right? Could be encrypted. We also see that there are a couple of encrypted packets where we are able to figure out that this is IP, TCP, UDP, DNS, etc. Interesting. Now, similarly, we can also just do the top layer. So we get a breakup of the high level protocol, which is in there. And we can see we found, data, ARP, HTTP, DNS, TCP, right? So whichever is the highest layer in the packet is the one which gets taken and is used in the formation of this tag cloud. Fantastic. This is very, very useful because it can give you an idea about the overall composition of your packets. Okay. The next thing we look at is, fields which give us channel information. Now for access points, the channel information is available in WLAN MGT DS current channel. So the DS parameter in a beacon frame gives the current channel of the AP, which we can see here as a value 56. Now we know that 11N and 11AC can have channel bonding, and when you have channel bonding, in the case of 11N as an example, you have a primary channel and then you have a channel offset, and in the case of AC, depending on if it is 80, 80 plus 80, 160, whatever may be the scenario, you could have two different centers, center 0, center 1. and of course a couple of other parameters. Now, from a pure security perspective, this might not be very interesting, but we've still kept those fields in there because we've seen a lot of clients at times want to really understand, how the APs are behaving around them. So you could use these channels. Of course, you would have to read a bit more to understand how to use these fields and how channel bonding works. Now, the field we do use all the time is WLAN MGT DS current channel. MGT stands for management, and this gives the current channel of the access point, which is send out the beacon. So going back here, let's actually first filter for beacon frames. So I'm going to do a WLAN frame name is beacon. And for beacon frames, I want to basically see the WLAN MGT DS current channel. Here it is. You can see this is channel 56. Fantastic. Of course, you can also go ahead and visualize this, right? And this would actually give you, of course, at this point, the larger something is means there are more beacon frames sent out by access points on that channel. So we can see channel 6 seems to have the highest number of beacons being sent out by different APs, followed by 4. Interesting to actually even see a 5 gigahertz channel, channel 40 here. And then of course you have a huge spread, right? Depending on APs, whether they are configured in the 5 gigahertz band, the 2.4 gigahertz band, and all of that. But this does come in very handy, and you might have seen or you're about to see in a future video how we use this to create interesting dashboards to understand where APs are, what channels they're occupying, etc. So this is a very useful parameter. Okay. Now, one of the other interesting fields which we put in is the WLAN MGT country info code. Now, many access points support that you can go ahead and change the country, and based on the country you're setting on the access point, it will automatically figure out the channels, the maximum transmit power level, etc., based on internationally agreed upon regulatory domain settings. So the info code basically gives you the 2-digit country code. And after that, you also have WLAN MGT country info FNM. And this gives a quick summary of what is valid for that country. And then you have a couple of other fields such as FNM FCN, which is nothing but the first channel number. FCN stands for that, 36. And then you have the MTPL, which is the maximum transmit power level, which you can see is 30 dBm. And a couple of other parameters. Now, where this is interesting is, as an example, currently if you're in the US, typically you should not have an access point in the vicinity which has been set to another country. Why? Because that country may go ahead and have a channel which might be disallowed here, and which means the AP is violating regulatory domain settings. And someone from the FCC can come knocking at your door if it is probably one of your enterprise access points. Now, the reason why this is problematic is because a lot of client device drivers, when they see this field, they automatically go ahead and if they have to connect to that AP, will change channels. So as an example, if I had Japan set and I was using channel 13, a client would happily hop over to 13, even though we are currently in the US, and communicate with that access point there, which would be a violation of spectrum use. So this is important to note. So let's go ahead, look at WLAN MGT code. And again, this is going to be in a beacon frame. So let's visualize this. So we have US. Sometimes I've also seen lowercase US as well. But if you notice, there are some beacon frames which also are advertising the country as China. Now, which means all of these are probably in violation. So let's click on this, and here is where the filtering part comes in. Let's click on this so we only have China. Now let's actually make both of these filters sticky so that when we go back to the discover mode, these filters remain. So I'm going to go ahead, make this a sticky filter, make this a sticky filter, and then go back to discover. And we can clearly see there are around 228 hits. Let's actually look at one of them. So this access point syllable 5G in the vicinity is actually using CN as the country code. And if you notice, this is problematic, right? And we've been able to discover a violation using our software. Fantastic. Many a times this can even be useful in detecting rogues which may have been put on channels which should not be used in that country. We keep seeing that when we do a lot of pen tests and audits for Wi-Fi. Okay. Last but not the least, of course, we have encryption related. So for encryption, there are a ton of fields in there, and you will find many fields which are there. Now, you don't specifically need to know every single field related to encryption in a beacon frame, simply because there are too many of them. What we have done to make this very simple is we have abstracted these out to 4 core fields. The first field is encryption status, and this will tell you if encryption exists, and if it does, is it, as an example, no encryption or WEP or WPA personal, WPA2A personal, or has both WPA and WPA2 enterprise, etc. Now, for most people, this is a lot of good information. Along with that, we also have WLAN MGT key management, which will be either PSK or 802.11 for enterprise. Then you have pairwise cipher, which again is going to be either AES or other options. Now for access points which have WPS enabled, we also provide the WPS version so that this has WPS enabled and the version of WPS. So let's look at some of these fields. I'm going to actually directly find the encryption status field. You can already see a lot of variation. Let me click visualize, and I can see WPA2 personal, so many frames. No encryption, which means this beacon frame clearly says this AP does not require any encryption. We also have WPA2 personal, again an access point which advertises both modes, and enterprise, of course, or mixed mode enterprise here, even WEP. Wow. So let's go back. So this is the encryption status field. Similarly, you have the key management field. So if we go ahead to WLAN MGT key management, here it is. We can clearly, of course, see that there is going to be just 2 values. One is PSK, which is for personal, and another is 802.11x, 802.1x, my bad, which is really for enterprise. Let's go back to discover. Then you have pairwise cipher. So if we go down here, here it is. And you have a bunch of options, AES, TKIP, or both TKIP and AES can be allowed in mixed mode. Of course, none where there is no encryption. And in the case of WEP, it's just WEP. Fantastic. Finally, you also have WPS version. Of course, the version itself is not very useful at times, but we can apply a very simple test. We can say WPS version exists. So which means if this field exists, then that access point supports WPS. And you can see these are all frames from access points, which are beacon frames, which have that field enabled. Here you go. Right. Now, a lot of times these values are basically what's mentioned in the standard and may have, kind of a mixed interpretation at times, depending on, some of these values, maybe even bit fields. So keep that in mind, and not to sway literally for the exact value, but rather to understand what the value signifies. So as an example, let's say if I wanted to look at basically the SSIDs with WPS enabled, what I would do is first I would apply a WLAN frame name, or what I would even do even more smartly is basically say access point SSID exists, right, which is there is an SSID, and then basically say, well, WPS version exists as well. So now we have all of these beacon frames which have the WPS element in them. And as you can clearly see, if I were to remove this filter, this is almost 9,000, while when I apply the filter, it's actually much lesser. And just as I showed you with the tag cloud, you can plot this, and there are other videos where we talk about how you can create your own visualizations. I'd recommend seeing them. Fantastic. So this is how we've actually simplified for the operator to be able to play with encryption. Now, these are the core fields which we would kind of hope that the operator would like to use and create their own data tables, visualizations, etc. Now, you may find there are many other fields as well. Some of those fields are experimental. Some of those fields have been used to create many of these macro conclusions like encryption status, etc. And ideally, we would not want to work with those fields directly because they are extremely raw. And as I said, just use so that we can build other macro fields. However, if you're interested, you can pick up the field name, and based on that, you should be able to compare it with the Wireshark packet trace and understand what that field stands for. But as I said, neither is it recommended. Also, fields which are not documented this way might be removed in a later release if we think it is redundant. So though not officially supported, feel free to still play with it. Okay, fantastic. So that's all I had in mind for this video. I know this was a long one, but this is a very important video, so I hope you finish till the end. Thank you, and have fun playing with your WiMonitor Enterprise.